Hello everybody, my name is Craig Bennett, and I am the founder and owner of Tech Reviews and Up. And today we are going to talk about orbital mechanics, and more particularly on thrust versus weight ratio. Now as far as delta V, I already got a video on that recorded, and I just got to edit it and upload it. But as far as this goes, I just wanted to get it out of the way so you guys know how to use thrust versus weight ratio. I already done a video before just talking about minor things with MechJab on it, but this is the math side. As far as thrust versus weight ratio, what is it? It's basically a algorithm that shows you if your rocket will be able to take off at all on a planet, moon, or whatnot. As long as you know the gravity constant for the planet, moon, or whatnot, you will be able to figure this out pretty easily. Now, with this in mind, if you have multiple stages, if you're doing this as a hobby, I don't see any way. I mean, besides doing thrust versus weight ratio for stage 1, the takeoff part, then or whatever you want to name your stages, but the launching, I can see where that's coming to use. But there's no way a hobbyist is going to launch something to the moon and back. If you do, then my hat's off to you, but to be honest, that's just not going to happen. No one really has that much money out of pocket, and most likely it's a company that's doing it if you're going to the moon and back or something like that. So, as far as things goes, what we're going to be talking more about is Kerbal stuff because that's more realistic. Or say you're going to school and trying to learn this. Now, with thrust versus weight ratio, there are several things you need to know. And right here on the bottom right, also somewhere on the screen, I probably have it, is the calculation. Thrust versus weight ratio, the basic way to calculate it is TW equals thrust versus weight ratio, T equals thrust, and M equals mass or weight, how much weight, in tons. G equals the constant gravity. Now, as far as G, this can change depending on exactly where you are. For example, G on gravity for Earth, the constant rate is 9.807 meters per second squared. Now, as far as that goes, all you need to know is 9.807. And that's important because that's 1 G. And let's say you're going to a planet with 2 Gs. You just need to double that number. So basically what I'm saying is if you're planning to put say let's use Apollo 12 for example. The Apollo 12, they put a lander on the moon and they launched the lander off, or part of the lander off, and brought back to Earth. Well, they had to use the first few stages in order to get up into space. So putting that all together, they had to use the thrust versus weight ratio for those stages. Now, as far as the lander part, they use a new thrust versus weight ratio for the moon. They had an idea of how many G's are on the moon, and I think it's like a third or fourth. I don't remember the exact, but you just need to divide that by 9.807. Or what you can do is just take the constant of the moon and use that. So right now, if we're launching from Kerbin or Earth, the G will be 9.807. While let's say you're launching from you're launching from somewhere that has 2 G's, you'll be just changing the G to 19.614, just doubling the number. Simple as that. So that's the basic way to put it. Now, with this being said, because most likely you're going to use this on Kerbal Space Program, because I doubt that you're going to be able to send something to the moon or something like that. But on Kerbal Space Program and pretty much everywhere, that's not the real world. You need to send a rover to detect the constant of G at the sea level, the lowest point, because the constant changes the higher you get away from the sea level of the planet being the lowest point. And this is important because if you want the exact thrust versus weight ratio, which may or may not be important depending on how strong your rockets are, this may or may not be important as far as you or whatever getting off the planet or moon. So that's kind of important. So basically, send a rover. If you're on Kerbal Space Program, just go ahead and send a rover over to wherever, and that way you can get a reading. How you can do that on Kerbal Space Program is use this device. It's a vanilla device. Just slap it on there and activate it, and there's that. In fact, let's put this on here. Now, one thing I want to note is before I put it on here, if you look at the vessel mass, this will change and that will change the entire thrust versus weight ratio. Probably not by much. I mean, it's so little it's not going to show here, but still. Now, as far as things goes, let's take this out so I can show you how to use that gravity thing, so you can actually take your stuff over and see the exact gravity. Try to let it load in a little. And what you need to do is toggle display, and right here it says 9.81, and the real number is 9.807, but it's pretty close. I wouldn't be that dependent on fuel if I was you. Just in case if something goes wrong, you need to have a little bit extra fuel, so that's important. Now, and also an extra kick for your rockets. So that's also important. The more fuel you have, the worse off you'll be as far as the weight, but the kick is what you need to look at, and you need to, just in case if something goes wrong, because I mean this is a computer game, there's no constant. Even in the real world, there's some variables, unknown variables, that causes problems once in a while. Now I'm going to probably take that off so we can move on to figure this thing out real quick. Now as far as things goes, this will not tell you how far up you're going to go. It's just that you will be able to get off the ground. In fact, let me show you something. If you look at the thrust versus weight ratio, which is 1.02, let's throw in a and as you see here, there's no fuel, but it's saying, hey, it's good to go. Has enough kick out of that one engine. That's it. The delta V is what will tell you how far you're going to get off the ground, either being an inch or whatever. And in this case, in case you didn't know, you're looking at 4,500-ish in order to get an orbit around Kerbin, and that's a low orbit. So, as far as thrust versus weight ratio, how do we figure out this with math? We need to know the total mass in tons, the fuel, oxygen, capsule, everything. And this is 143.82 tons. Again, you need to know it in tons. And the thrust you need to know in kilonewtons. So that's 1440, and that's in kilonewtons. Now, using the mathematical formula as is shown here, what you need to do is 9.807 times 143.82, and oops, sorry about that, and save that. 1440 kilonewtons divided by our answer, and as you see here, 1.02, so on. So that's pretty much it as far as that goes. So we know it will take off. Now, as far as things goes, again, if something's 2G, just double that number, or you can keep it the same. And if this shows 2 or more, then you'll be fine. Just imagine this number being like 1.02G at the maximum that it could take. So if it's at 1G, then this thing's still gonna go up. If you're trying to escape a 2G world, a 2 times gravity world, then, and this is 1.02, it's not going to move at all. So you can also manipulate that. And so you have 2 choices. If you're trying to escape the moon or whatnot, you can manipulate the G, or you can look at this and calculate it from that and figure out if your stuff will escape the moon or whatnot. It's a pretty simple deal. And that's this number always stays the same as far as 9.807 within the MechJab. So that's where knowing how to calculate this stuff can help outside of MechJab. So let's take this thing off, and I probably will head out because this thing takes a while to get up and to crash. That's also pretty loud. But anyways, it's pretty much it as far as thrust versus weight ratio. If you got any other any questions at all, feel free to leave them in the comment section, and I'll try to help you out as much as possible. And you can leave a comment below, email me on techreviewsandhelp.com, or email me on YouTube. And this has been Craig Bennett. If you found this video helpful, then please like, please subscribe, and please share.